Ever gaze at the night sky and wonder, are we alone in this universe? This profound question has puzzled mankind for centuries. We're stepping into the realm of the unknown, a realm of infinite possibilities and unanswered questions. Today we delve into the paradox that revolves around this enigma, Fermi's paradox. This paradox, named after the renowned physicist Enrico Fermi, poses the question of extraterrestrial life's existence in the vast cosmos. This question is the heart of what's known as Fermi's paradox. Fermi's paradox, named after the physicist Enrico Fermi, poses an interesting dilemma. Picture yourself on a quiet night, gazing at the vast expanse of the star-studded sky. With countless galaxies, each containing millions, if not billions of stars and possibly even more planets, one can't help but wonder, are we the only ones here? Fermi's paradox is the very embodiment of this question. It's a contradiction of sorts, a cosmic enigma that twists and turns our understanding of the universe. With an estimated 2 trillion galaxies in the observable universe, each potentially teeming with planets and moons, it seems statistically improbable that Earth would be the only celestial body harboring life. Now, if we consider even a tiny fraction of these celestial bodies to have the right conditions for life, the numbers are still staggering. And if a sliver of these life-supporting planets have species that evolve to develop advanced civilizations capable of interstellar communication or travel, we're still left with a considerable number. Yet here we are, seemingly alone in the vast cosmic ocean. Our radars remain silent, our messages to the cosmos unanswered. No extraterrestrial visitors have made contact, nor have we stumbled across any signs of alien civilizations in our cosmic explorations. The universe, for all its vastness and potential for life, appears eerily quiet. This is the crux of Fermi's paradox. Despite the high probability of extraterrestrial life, based on the sheer number of stars and planets out there, we have yet to find any evidence of their existence. It's as if we've arrived at a party with trillions of invitations sent out, only to find that we're the only ones who showed up. Why is that so? What could possibly explain this deafening silence? Are we truly alone, or is there something we're missing in this cosmic puzzle? These questions are at the heart of Fermi's paradox, pushing us to look deeper into the mysteries of the universe. So, where is everybody? That's Fermi's paradox? To understand this paradox, we must first grasp the Drake equation. Named after astrophysicist Frank Drake, this equation is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It takes into account key factors such as the rate of star formation, the fraction of stars with planetary systems, the number of planets that could potentially support life, and the likelihood of life developing into intelligent beings capable of interstellar communication. Imagine a cosmic lottery where each factor is a winning ticket. The more tickets you have, the higher your chances of winning. Hence, the Drake equation multiplies these factors together to give us an estimate of civilizations that might be out there trying to reach us. Yet despite these astronomical numbers, we have no concrete evidence of extraterrestrial life. One theory that offers an answer to Fermi's paradox is the Great Filter. Imagine, if you will, the vast expanse of the universe as a racetrack, and each civilization a runner. They're off to a great start, evolving from simple life forms into complex organisms, developing technology, and eventually setting sights on the stars. But somewhere along this track there's a hurdle so high, so daunting, that it brings our cosmic race to a standstill. This, my friends, is what we call the Great Filter. The Great Filter theory, proposed by economist Robin Hanson, suggests that life, in its journey to colonize the galaxy, faces an insurmountable barrier. This filter could be anything: a catastrophic event, a technological mishap, a biological disaster, or something entirely incomprehensible to our human minds. The concept is haunting in its simplicity. It explains the silence of the cosmos by suggesting that civilizations, including our own, might be doomed to self-destruction. With the universe being as old as it is, there should be enough time for at least one civilization to colonize the galaxy. Yet here we are, seemingly alone. This leads us to the existential crossroads of the Great Filter theory. Have we, as a civilization, already passed this filter? Have we overcome the greatest challenges to life and survival? If so, we might be one of the fortunate few, if not the only ones, to have done so. On the other hand, if the filter is yet to come, it could be a grim future hurdle that we are destined to face. We might be on the precipice of a great disaster, a catastrophe so profound that it halts our progress and leads us down the path of extinction. So let's ponder on this thought. The Great Filter Theory offers a compelling answer to the Fermi paradox, but it also leaves us with a chilling question. Could we have already passed this great filter, or is it still lying in wait, a grim future hurdle? Another intriguing theory is the zoo hypothesis. This proposition is quite a fascinating one, suggesting that we, the human race, are being observed by extraterrestrial life like animals in a zoo. Picture this. Imagine that there are advanced civilizations out there in the cosmos, civilizations so advanced that they've managed to navigate the stars, explore numerous galaxies, and have technology that would make our most cutting-edge advancements look like child's play. Now, imagine that these advanced civilizations have come across Earth. They see us with our wars, our joys, our struggles, and our triumphs. They watch us, much like we watch animals in a zoo, observing our behavior, our society, and our culture. Under this hypothesis, these extraterrestrial observers have chosen not to interfere or make contact, for a multitude of possible reasons. Maybe it's because they want to allow us to develop naturally without external influence. Or perhaps they are waiting for us to reach a certain level of technological or societal advancement before they reveal themselves. It could even be a prime directive-like scenario, where non-interference is a universal law among advanced civilizations. It's a theory that raises many questions about our place in the universe. Are we alone? Are we being watched? And if so, why? The zoo hypothesis is yet another theory that attempts to explain the eerie silence in our search for extraterrestrial life. Are we, unknowingly, the star attraction of an intergalactic zoo? A more futuristic theory is the transcension hypothesis. This intriguing concept suggests that as civilizations become more advanced, they inevitably leave our universe. But where do they go, you may wonder? The answer might lie in the singularity of a black hole. The transcension hypothesis, proposed by futurist John Smart, is an answer to Fermi's paradox, which asks why we haven't encountered signs of extraterrestrial intelligence. Smart suggests that civilizations follow a predictable developmental path, referred to as stem compression, the compaction of space, time, energy, and matter. As civilizations become more technologically advanced, they miniaturize and accelerate, eventually leaving the perceivable universe and entering a black hole-like domain. In essence, this theory posits that advanced civilizations might not be expanding outwards into the cosmos, but rather inwards, towards the infinite densities of black holes. They could be creating micro-universes, transcending our reality and essentially disappearing from our perception. It's an idea that's as fascinating as it is eerie. The thought that civilizations might not just be out there, but in here, in the heart of a black hole. Yet, this hypothesis is not without its critics. Some argue that it's based more on speculation than empirical evidence. However, it does provide another possible answer to the question that has puzzled scientists for decades. Could advanced civilizations be disappearing into black holes forever beyond our reach? Despite these theories, Fermi's paradox remains an unsolved mystery. As we delve deeper into the cosmos, this paradox, named after physicist Enrico Fermi, continues to perplex us. We have journeyed through a myriad of theories, from the Drake equation, an attempt to estimate the number of civilizations in our galaxy, to various theories of silence, such as the Great Filter, the zoo hypothesis, and the transcension hypothesis. Each theory, while thought-provoking, only deepens the enigma. The Great Filter suggests a stage in life development that no civilization can surpass. The zoo hypothesis surmises that advanced extraterrestrial life is watching us, like animals in a zoo, without making their presence known. The transcension hypothesis posits that civilizations inevitably leave our universe, perhaps to explore or inhabit other dimensions. These theories are not definitive answers, but stepping stones, guiding our ongoing search for extraterrestrial life. They fuel our exploration and curiosity, encouraging us to push further into the unknown. The importance of this search cannot be understated. As we continue to probe the universe, we not only seek other life forms, but also strive to understand our place within this vast cosmic tapestry. Yet, despite our progress and the compelling theories we've discussed, the paradox remains. We look up at the twinkling stars, at galaxies far beyond our reach, and the question continues to echo in the silence of the night. As we continue to search the cosmos, we keep asking, where is everybody?